So in the last video, I asked a question that according to Rayleigh's law of scattering, the amount of scattering is inversely proportional to fourth power of the wavelength. Even though violet has the least wavelength, we see the color of the sky to be blue. Why? See, the reason is our eyes are sensitive to blue color, not violet. Even though violet is the most scattered light across the atmosphere, since our eyes are sensitive to blue, we see blue color to be the sky, the color of the sky. Okay. Now, this also explains, see one more thing, that the wavelength of the light, whatever we have, is almost half that of the red light. Okay, it's half of it. So since it is inversely proportional and it is fourth power, what we get is the amount of scattering will become 16 times. That means the blue light is scattered 16 times as much as the red light. So this is the reason why sky appears to be blue. Okay. So and lot of other examples also we can give. See, one more example is whenever you see a building which is very tall, you see a red light which will be blinking on the top. Have you noticed? Now the reason behind this is red light scatters the least, correct? So even though let's say there is clouds and mist and all those things, the red light can be seen from a very far distance. Okay, very far distance. So this is the reason why red light is used. Even for danger signals also, we use red light. Okay. And one more example which we can give is clouds are white in color. See here, clouds are made up of just water and dust particles, correct? Right. So the atmosphere particles, whatever we have, those particles will scatter the light, whereas the cloud particles are much larger compared to that of the atmosphere particles. Okay. So because of this, the clouds appear white. Okay, because of this the clouds will appear white. So we have n number of examples like this. So one more very important example is rainbow. See, when we talk about rainbow, actually there are two rainbows. One is a primary rainbow, one is a secondary rainbow. Okay. Now both the rainbows, this is because of scattering of light. Okay. But before scattering of light, there is one more thing. The total internal reflection also happens here. Okay. Now what happens is when there is let's say water droplets will be there in the atmosphere. So when the ray of light comes and hits the water droplets, it undergoes total internal reflection. Okay. So as it undergoes total internal reflection, the ray of light will emerge from the water droplet. That causes dispersion. Okay, that causes dispersion. So whenever there is rainbow, two optical phenomena will be happening. One is TIR, the total internal reflection, and another is dispersion of light. Okay, as there is dispersion and also there is scattering of light, because light is being scattered here, correct? So this is why rainbow appears, or this is how rainbow appears, and this is how we can explain how a rainbow appears. Okay, so these are different examples of scattering. There are a lot of other practical applications. So you guys can go through different types of applications by your own so that you will understand the concept better.